This is a special report from ABC News Digital.
Hello everyone, I'm Ty Hernandez in New York with this ABC News Digital special report. A mission to Mars could tell us about the Earth's future. We believe Mars once had an Earth-like atmosphere, but something changed, and that is what we are all set to investigate. NASA is sending a spacecraft to find out more. The Mars atmosphere and the volatile evolution, or MAVEN mission, will take off on Monday and for the first time analyze Mars' upper atmosphere to solve a 4-billion-year-old question. What made Mars turn into the cold red planet we see today? To answer that question, let's bring in Goddard Chief Scientist Jim Garvin at the Goddard Space Flight Center in Greenbelt, Maryland. Jim, good morning to you. Good afternoon. So,
good morning and afternoon to you.
Yeah, we're sort of in that midway point. Tell us about the MAVEN space probe. What is it going to do?
So MAVEN is a reconnaissance mission. It's kind of like a detective flying in orbit around Mars to read the record of how the Mars atmosphere, really tiny, rarefied atmosphere, escapes and evolved in the presence of space. And Mars lives in space. Its atmosphere constantly interacts with space. How all that works, the physics and chemistry, is critical to taking the Mars of today and figuring out how it got to be that way relative to that exciting Mars of the past, whose record we see in the signs in the rocks from the Curiosity rover, a warmer, wetter, better climate place, the kind of place we want to ask, were we alone? But the Mars of today is very different. MAVEN will start to piece together that puzzle for us with up-close measurements of this exciting planet.
So I think you answered my next question there. How do we know that Mars once had an Earth-like atmosphere, and how do we investigate why it changed? You know, what samples will MAVEN take, or pictures will MAVEN take, that can answer that question for us?
So we know Mars was warmer and wetter, had a different climate state in many ways. Today, the Curiosity rover on Mars has incredible equipment, instruments developed across the world, even here at our Goddard Space Flight Center, that can read the chemistry of the rocks, suggest warm, wet, all the right ingredients for a habitable world in the past, but billions of years ago. That record is long gone, lost in time, if you will. So we need to connect that to the Mars of today, which looks forbidding. It's extremely cold, very dry, all the water's locked up in ice, in minerals, in small amounts of water vapor in the atmosphere and on the polar caps. So that's a big storyline. How do we connect them? MAVEN to the rescue. Make the measurements of the modern Mars atmosphere, how it works in space, connect the dots back in time to what we see in those records from the Curiosity rover, from Opportunity rover, from Spirit rover, from our previous missions. Put them all together. We're trying to paint a masterpiece here, and we haven't gotten all the little colored squares yet ready to paint, but MAVEN will fill in many of them.
We often talk about saving the Earth's environment, saving the Earth's atmosphere. Do you think that there'll be any lessons learned in terms of what happened on Mars?
Absolutely. The record on Mars is like Mother Nature's great control experiment. Good planet, right conditions, something happened. And here on Earth, we have this wonderful biological world that we live on, our priceless home planet. And we can't predict all the future consequences of what could happen. We live in space. Space is a very unpredictable place, as we've seen with meteor showers and all that kind of stuff. So we need to see how we live in space. By being informed by the history on Mars, we'll know some of the things to expect. We'll be able to look back in time on Mars, compare it to our own records here on Earth, and project ahead. And that's why comparing the planets of our solar system as we look here, and even look to new solar systems beyond our own, is so important in finding our place in space.
We always talk about the possibility of life on Mars, or particularly in the past. Will MAVEN shed any light on that?
Absolutely. MAVEN is a mission about reading the history of the atmosphere and finding about how habitability works. The right conditions in the atmosphere, in the climate state, in the magnetic field, all that stuff is critical to allowing life to get a foothold. If Mars had that chance, would be wonderful if it did, we're still looking, then we need to know, well, what went wrong? Or where did it go? How did, if there were any, Martians adapt? We don't know those questions. Mars is the best first place to look for life beyond Earth from what we know today. It really is. And so, are we alone? We go to Mars. MAVEN fills in one piece of that puzzle for us. This question of habitability looking through the lens of the atmosphere. Very important step we've wanted to do for more than 30 years. And now we're doing it.
Now, correct me if I'm wrong, but I believe that there are two reigning theories about where Mars' atmosphere went. It either escaped upward into outer space or it fell into the soil. Can you explain those scenarios?
Well, there's different models. There are storylines on what might have happened. Certainly, the Mars atmosphere is continuously lost at some level to space. But the consequences of big perturbations, gigantic impacts of comets and asteroids, combined with the small nature of Mars relative to Earth, could lead to other mechanisms for loss. One of them suggests that those big impacts blew off some of the atmosphere. What was left is what could be retained by a small planet, perhaps produced by volcanoes emitting gases, outgassing, producing the modern Mars atmosphere. Other questions are, Mars atmosphere is a big chemistry lab, a big chemistry set. Some of it interacts with the surface, producing the red dust that we see on the rocks from Curiosity and Opportunity. That allows us to say, well, maybe the atmosphere is in a continuous chemistry experiment. Some of it changes, some of it is lost. Remember, Mars is only 40% the size of the Earth. Its atmosphere today is on the order of 1/1000th of the Earth. So we're looking at a very different system. And that's important as we understand what it could have been in the past and where it is today.
Now, MAVEN is going to leave from Cape Canaveral on Monday, but it takes quite a while. You have to be quite a very patient scientist to wait for MAVEN's arrival. How long is this trip going to take?
Well, it's going to be a 10-month voyage. That's as long as the first leg of Magellan's great trip around the first orbit of Earth in the 1500s. So long trip, long way. MAVEN goes the very slow, careful, safe way to Mars. It'll fly for over 400 million kilometers to get there, conduct a special maneuver to go into orbit, and start its science. So we won't begin our science mission until next fall. But we're used to being patient as time goes in space, and that gives us time to learn about Mars from Curiosity and other missions and get ready for the onslaught of data from MAVEN, which will be a treasure trove.
Now, many people, while MAVEN is set to launch, are very much looking forward to the first manned mission to Mars. We see that one of the challenges is, frankly, it takes a very long time to even get there. So when in the foreseeable future do we think a manned mission to Mars would be possible, and what are some of the challenges standing in the way?
Well, first, people to Mars, is a dream for most of us. I mean, it is the long trip, the great voyage, maybe akin to the Renaissance voyages of 500 years ago. But it's really hard. President Kennedy said it's hard. So it is. It's so much farther than the moon. And we're just learning on our International Space Station now some of the things it takes to live and work in space for 10 months just to get somewhere. So that's an important first step. We're doing that. We're exploring Mars with robots like MAVEN and Curiosity, with a new rover in 2020 that we hope will collect the right samples to someday be brought home to Earth. These are steps toward getting ready to send human beings, women and men, to Mars. We need to practice the engineering to make that round trip ready for people because it's so far, thousands of times farther than the Earth's moon was from Earth. We can do this. The engineering community of this planet is ready to take on that challenge, but we need to do it with our eyes wide open to the real Mars. Mars is an unforgiving place. We need to get to know it in order to go there ourselves. I'm hoping in the lifetime of our children, we will see that time come. The history books will change as people go to Mars.
And as you said, thanks to Rover and MAVEN for paving the way. Got our Chief Scientist, Jim Garvin. Thank you so much for joining us. And for more on NASA's new mission to Mars, be sure to check out abcnews.com right here. For now, I'm Ty Hernandez in New York.